This is my lab report for Lab 1 charged tapes. In this experiment, we will create two positively charged strips of tape, and because like charges are repulsive, we'll be able to float one strip of tape over the other. Our problem is to find the charge and the number of excess electrons on one strip of tape using data we have gathered experimentally and a simulated model. In this report, I will first go through the physics principles relevant to the phenomenon, and then the physical experiment we used to gather the initial values that we'll input into the glow script model of 2-point charges, and then results will be discussed along with a few what-if questions. So there are two fundamental physics principles at play. The first is Newton's second law, which states that force is equal to the change in momentum over the change in time, if the velocity is 0, that means the momentum is also 0, and that net force on an object is 0. And the second principle is the principle of superposition, which states that every charge in space creates an electric field at point independent of presence of other charges. So any charged object, such as our strips of tape, will produce an electric field. And when we combine these principles, we find that because one piece of tape floating above another has 0 velocity, the net force on the tape must also be 0, so the force of the electric field is equal in magnitude to the force of gravity. And here's an illustration I made to show that. You can see the force of the electric field in the positive y direction, and then the force of gravity in the negative y direction, and because these are in equilibrium, they are stationary, there's no motion, so we know the net force is 0. And for the experiment, I created two positively charged strips of tape and observed the reaction of various objects. Because of this charge, the tape was attracted to my hand and a plastic pen, which both have negative charges, and was repulsed by the other positively charged strip of tape. And in order to be able to measure the charge of the strip of tape, I floated one piece of tape over the other and measured the distance at which they were in equilibrium, and this value will be used for my glow script code. And here you can see my model and glow script. The green arrows are for the electric field, which you can see are pointing opposite to one another, and then the force of gravity going down. And here are my constants and initial conditions. I'm not going to read them out, but you're welcome to pause. And then here's the calculations. As we discussed before, we have the force of gravity, we have force net is equal to 0. And this is the approximate equation we were given in the experiment to help us find Q with the assumption that the charges are equal. And then here's how I algebraically found Q in terms of the force of gravity, and then the distance and the K constant. And then here's how I input that into glow script. You can see on line 26 where I have that formula to find the charge, and then also to find the surface area, the number of atoms on the tape, and the number of excess electrons along with the ratio of the two. And then here's how I did all of my graphics with the arrows and the balls. And then for the results of the model, what was the magnitude of the charge on one piece of tape? I found it to be 1.2 times e to the negative 8th coulombs, which at least qualitatively is accurate because it is indeed positive. And then we're also asked about what approximations we made to determine the amount of charge on the floating tape. And one, I treated the tape as though it were a point charge, and I also assumed that each upper tape or positively charged tape that I made had about the same amount of charge that was evenly distributed along the length of the tape. And then our first what-if question about if electrons had a positive charge and protons had a negative charge, what would change, what would be the same? And in a lot of ways, the behavior would still remain the same, because charged strips of the same charge would still repel one another, and then oppositely charged objects would still attract. So the two strips of tape would still be in equilibrium and floating. So the charge I calculated for a single strip of tape would change signs, but the magnitude should remain the same. And our other question is, why is it important to handle the charged tapes as little as possible? So electrons flow from areas of high electric potential to low, like water flowing downhill. So if a negatively charged object like your hand comes into contact with a positively charged object like a piece of tape, electrons will be transferred from the tape until they are in equilibrium, thereby decreasing the positively charged and then less noticeably decreasing the negative charge. And in conclusion, I found the charge of a strip of tape once again to be 1.2 to the -8th coulombs, and the ratio of excess electrons to atoms on the sticky surface is about 1 to 6.9 times 10 to the 6th, which is a lot. And I modeled the behavior of two positive point charges in space through the glow script and the use of Newton's second law and, of course, the principle of superposition. And in the future, to increase accuracy, I'd like to be able to use more precise measurements of mass, distance, and the distribution of charge. Thank you.